This deadly danger still threatens fighter pilots today. In the Research Center of the U.S. Air Force in Dayton, Ohio, engineers are still searching for an optimal way to perform an emergency exit, causing the least amount of injury possible. The equipment and ejector seat are real. The crucial difference is that in place of a real human who could injure muscles and bones is a dummy full of measuring instruments and sensors. The catapult will accelerate the seat in a split second from 0 to 50 kilometers an hour. During this experiment, the dummy has to endure 20 times its own weight. The experts call this 20 Gs. In the event of a real ejection scenario, the forces acting on the pilot's body could be much greater still. Where is the limit? What forces can a body withstand? Researchers are still referring to the data from the 50s for which Dr. Stapp risked his life. Using a rocket-propelled sledge, he upped the forces acting on his own body from one experiment to the next. Stapp's self-experiment surpassed everything that had been thought possible until then. In just a few seconds, he braked from more than 1,000 kilometers per hour to 0. His body had to withstand more than 45 Gs, a weight of more than 3.5 tons. Stapp survived with only minor injuries and thus proved that an astronaut would be able to exit a rocket even at high speeds.
Once you survive that, now you have to get down to a lower altitude because the true airspeed that you're going at is phenomenal. And there's no density there. So when the parachute opens, it opens at an extremely high rate, and it will destroy the parachute. And not only that, it'll give you a very high G.
So the life-saving parachute can also severely injure a pilot. The faster he's going, the worse it is. The researchers from the Air Force are working on providing the best protection for the pilots as possible. Pilots today have the following safety rule. The parachute opens only when they're below 20,000 feet.
The only way you can survive is to free fall down to below about 20,000 feet before you can deploy the parachute. That time, from the time you decelerate to down to the altitude, is a time that's you're very vulnerable to tumbling and spinning.